Using Linear Programming to Optimize an MLS Roster by Andrew Beitler. St. Louis City SC is a brand new men's professional soccer team that has joined the MLS this year. As a new club, it can be difficult to compete with established competition that have certain advantages, such as a larger salary cap and more experienced scouting and recruiting. More talent on a team typically translates to more success, but this talent comes at a cost, which is a problem because successful clubs make more money. This problem can be solved by using optimization techniques. Linear programming is an optimization technique that finds the best possible solution that satisfies all the constraints while optimizing an objective function. Using optimization techniques in sports has become increasingly common, and many people are familiar with the story of Moneyball, where the 2002 Oakland A's were at the top of the AL West by using optimization techniques based on statistics like on-base percentage plus slugging percentage. Since 2012, soccer has had a similar statistic, expected goals, which measures the quality of a goal-scoring chance by calculating the likelihood of scoring based on factors such as distance to goal, angle to goal, pattern of play, and position of the defense. This stat is a good indicator of offensive efficiency and is more in-depth than goals or shots on goal. My model consists of a deterministic linear programming approach in MATLAB using the integer linear programming function. The discrete search space consists of 888 MLS players as of September 2022, stored in a MATLAB table consisting of player name, position, compensation, and expected goals in 2022. The model formulates a team with the maximum amount of expected success subject to the constraints of player positions, total number of players, and player salaries. The optimum is a roster of 10 field players with the maximum number of total expected goals per 90 minutes and the sum of player salaries. The design variables are Boolean values defined as x sub n, where n equals 1 through 888. If a player is selected, x sub n will equal 1, otherwise x sub n equals 0. The objective function was defined as maximizing the sum over n of expected goals per 90 sub n times x sub n. The program is subject to the constraints of the number of players selected to the roster, which is defined by the sum over n of x sub n equals 10, the number of each position selected to the roster, where the number of forwards equals 2, midfielders equals 4, and defenders equals 4. Finally, salary, which is defined as the sum over n of x sub n times salary sub n, is less than or equal to $6 million. Here is the roster that was returned by the program for the constraints mentioned on the previous slide. The total compensation required is about $5.46 million, and the total expected goals per 90 minutes is 4.23 goals. Choosing 10 players from 888 yields about 8 times 10 to the 22nd possible combinations, and my model returns an optimized roster in 1.26 seconds. The constraints can be adjusted to return a different roster. Here are the results for formation with 4 defenders, 5 midfielders, and 1 forward, which is basically what St. Louis City plays. The budget for the starting 10 players was $5 million. As you can see, there are some repeat players such as Hani Mukhtar, who was MVP of MLS last year and scores a lot of goals, as he's the most expensive player returned by the program. And finally, plans for continued work. To improve the model, I would implement some measurement of defensive efficiency or goalkeeper performance into the program to better ensure success of the team, as a good offense isn't a guaranteed win. I would also scale up the design space with players from other leagues and adjust the constraints to include more specific positions, such as wingers and preferred sides for players, such as left back and right back.